Welcome you all to this class on easy cockpits. And in the last three lessons, uh, it was an introduction to easy cockpits. We went through what are the different display possibilities and color codes and etc. and how the cursor control device, how the pilot inputs data into the system, etc. We saw. Now it's time to move on and get to some specifics. Now this lesson is a specific menu, sub-menu options and explanations thereof. Uh, there are several uh, menus and sub-menus which are possible, but this particular menu, sub-menu is the logical start point, in my opinion, for you all to develop an understanding of the easy cockpit, and particularly so for this particular type of aircraft, Falcon. I'm sure the systems are similar for any other easy cockpit. Okay, let's recap a little bit as to what we learned about easy cockpit. I had taught you earlier that a lot of other display systems have been reduced to four basic displays in an easy cockpit, and these four, each display is configurable in smaller windows in two-thirds and one-third and half, and these windows can be combined in different proportions, different ways by the pilot for the appropriate phase of flight. That's what we learned. So I just put this, I just want you to recall and understand that. So that's what is the four displays which I've shown here. Okay, let's recap a little bit as to what we learned about easy cockpit. I had taught you earlier that a lot of other display systems have been reduced to four basic displays in an easy cockpit, and these four, each display is configurable in smaller windows in two-thirds and one-third and half, and these windows can be combined in different proportions, different ways by the pilot for the appropriate phase of flight. That's what we learned. So I just put this, I just want you to recall and understand that. So that's what is the four displays which I've shown here. Now, when the pilot selects this avionics menu, this is the display which is likely to get in the whichever two-third half window which he has selected. So as you can see, there are several horizontal tabs as we discussed earlier. The present tab which is visible and which is active is the init tab, and of course the underlying tabs are FMS setup, FMS speeds, tools, AFCS, custom DB and system configuration. So these are the tabs, menus which will open up further sub pages which the pilot will interact and input information or derive information as the case may be. So very interesting, and let's go on further. Okay, a brief explanation to the information on this particular page, init page. Firstly, the date and time as derived from the aircraft system, GPS, or whichever system is is the most accurate. And next is the dates of validity, etc., of the three databases. There are three databases. One is the navigation database, then the aircraft database, aircraft performance database, and of course the charts, instrument approach charts and airport charts, etc. The one of the first steps, the pilot will verify if these dates are appropriate. As you can see, and like in any other aircraft, the navigation database, the previous cycle database also retained, and the current database cycle is the current one. Recycling these two will mean the pilot is deleting all the existing loaded data and reloading, wanting to reload another set of data. That's what would mean. The third is the software number, which this of course would be normally be checked by the engineers when they do their action. And the fourth one is the code, transponder code. This is the call sign which the pilot uses, or this is the item which you will fill it in your flight plan in item number 7, and this will appear in all the air traffic control systems, wherever the secondary radars and displays, etc. So this is another important aspect which you should cross check whether it is correct or no. Now, one of the first actions which the pilot will ever do before a flight is to update the current position. As soon as the aircraft is powered up, as you know, the aircraft requires the current position to be known, to be fed. Normally, it memorizes the position where the aircraft had switched off the previous switch off position, and it brings back the current positions accordingly. But if you had moved this aircraft in between within the power off mode, then there is going to be a change in the position, and it may not be coherent. Either way, it's a good practice to update the current position. That means when it's powered up and pressing the update FMS position option here, the cursor is shown here, will bring up this particular window, update FMS position. Now the cursor can be scrolled up and down. Normally we update it with GPS 1 or GPS 2 position, which all will mean very, very close to each other. And so the pilot will select one of this, or if he knew, or if he found that the stand coordinates which are written on the stand is much more accurate than what the GPS, he can choose to update it using the other coordinates, physical coordinates as well. Either way, you select the figure and then press the apply button, soft key, the system is going to accept that particular GPS position. Okay, let us go to the next tab, that is the FMS setup, and let us go through the interactive portions one by one. Firstly, the smart performance learning. This, I think I should give a little bit explanation. When this avionics, when this cockpit was, when this provision was originally designed, it was meant that aircraft, as the aircraft flies, they would gather information automatically depending on the performance of the aircraft. But over a period of time, the manufacturers learned or realized that the database supplied is much more accurate than if you ever try to use the the system learned data. So in some cases, maybe it was erratic. So they recommended that it should be kept off at all times. And if at all you used it, it has to be used for flights more than only 600 nautical miles. That means for shorter periods, shorter leg length flights, these were not at all indicative or purely indicative. That's what it meant. Next is now smart performance mode. Full performance is deselected while flying a not normal profile. That means the system was originally designed for understanding the aircraft performance and comparing it with the supplied performance if it was performing long distance flights and over a period of time. But eventually we found that that is not necessarily the case. There are several times it leads to incorrect supply of information because pilots were resorting, needed to use it for short flights and for training flights where so many touch and goes and all this were involved. So learning on its own was not at all accurate. So the pilot stroke current uh, or the pilot speed FF would normally be used, and pilot current is selected only if full performance is not accurate. That means you had to feed every information on your own. So that's what is the thing. The best is to leave it at smart performance off mode. That means this particular section is not getting affected. The third is takeoff fuel and approximate landing fuel. This only gives the takeoff fuel, approximate fuel used from start to liftoff, and after touchdown to power off. This is the pilot fed figure, so that it will subtract that much, and it is able to calculate exactly how much fuel will be required for the burn off. And the last but not the least is RNP setting for legal requirements. Now, in this case, for departure, the requirement is 1 nautical miles, accuracy of the RNP, and en route is 2 nautical miles, and remote routes are 10 nautical miles, and once again, arrival approaches are 1 and 0.3 respectively. So these are set figures which normally we don't amend it for every flight. The next tab, in my opinion, it's very important, and every pilot must develop a very good understanding. And in my experience, I can advise you that before every flight, you must check the figures which have been fed in this particular tab, so that you are aware of any amendments from the standard ones which you may be used to if an amendment has been committed to by the previous pilot. So let us go through what this page essentially means. You are configuring the entire aircraft speed and automatic changeover of the speed profile for the entire flight, right from departure to arrival, which is going to take place automatically as the aircraft will be in auto mode. So that's what is this page indicates. So let's go through the sub selections one by one. First is the climb schedule. There are two modes. One is default and manual. So here default and what is selected, default and manual, is same. That is 260 knot and 0.74. Manual will be, it's the maximum speed that it will achieve for the climb profile. Next is the departure speed schedule when the aircraft is below 1500 feet or less than 200 feet in clean configuration. So that's what this you need to configure. That is the next is the airspeed restriction that is below 10,000 feet. So this is standard restriction nowadays for departure. So it's standard that below 10,000 feet you will keep 250 knots unless you have taken special permission and to have high speed during the climb. And if there is no other traffic, then probably the air traffic control will advise you. The next is The descent profile in auto manual mode, which is again very self-explanatory. You can, as you can see, there are several possibilities. Either you can indicate a speed in knots or maximum Mach number, or a glide path in terms of degrees. Normally, we would try to maintain a 3-degree glide path and accept whatever speed you get. That's what is here. You are going to use or you use the automatic profile which has been given by the aircraft manufacturer, or which has been fed on the ground. Now, next is the approach configuration speeds. That means as and when you lower your flaps, the system will automatically reduce thrust and bring the speed below and bring it to an ideal speed which is required for commencing the approach. In this case, as the pilot lowers the uh, flaps to when the flaps are in zero, the minimum speed the aircraft will come up to is 190 knots, and when the pilot brings to first stage of slat flap, then it will reduce it to 180, and slat flap 2 will be 170, and we approach as calculated by the aircraft. So now, when the pilot is doing an ILS, and if when there is a drop off of a localizer or glide slope, then it is possible because of some power fluctuation or some violent maneuvers, turbulence, it it unlocks from the localizer glide slope. Then the aircraft will go into the roll mode and it will try to get into, and if the altitude selected is more than 150 feet above the aircraft flight level, it will get to climb speed profile as we discussed earlier. Normally, we would have set the go around altitude before commencement of the final approach. So, if there was a even with the flap selected full, if there was a disconnect in the localizer or glide slope, the aircraft will aim to reach climb profile. That's what it means. And you need to be aware of this. So you can experience a change if there is a change in speed of the aircraft, if there is a disconnect of the localizer or glide slope. Lastly, not last, and approach speed changeover point. That means you are descending at 250. At some point, it has to drop speed from 250 to 190. In this case, clean this thing. It will be, if you had checked the checkbox of the first approach waypoint, it will commence the speed reduction at that point, or you can specify it in terms of distance to destination, which what is the normal standard practice, because the checkpoint itself may be at a much farther distance, and the air traffic control doesn't want you to reduce speed unnecessarily before they actually demand it. Next is the selection of go around speed. Clean configuration modifiable but not recommended, but other configurations are not modifiable. That means if you executed a go around during the approach, and as and when you raise the flaps, the speeds are going to increase automatically as it has been programmed, except that the clean speed can be manually be programmed. This, I think, it's a very, very important section, and it's for that reason I've taken so much time to explain this particular sub page, and I want everyone to understand this page because it is very important, because very unexpected things can happen if you have not configured it, this particular page, correctly. This particular tab, very self-explanatory. It gives the timer and alarm, that is the tools selection. Tools tab selection. UTC from aircraft, it's not modifiable. It's very self-explanatory. The countdown time in hours, minutes, and seconds. Of course, there is a start and there is a stop, and it will give an alarm in the cockpit. And the last one is, of course, an alarm in terms of UTC. And this timer, normally it is used when you are doing fuel equalizing or some such activity. So you want the aircraft, you want yourself to be reminded. So and of course UTC, if air traffic control advised you to report a particular event. It gives warning to the pilot in terms of oral timer and all oral alarm tones, which may be silenced by pushing the silence button in the cockpit. Very simple provision. Next again is a very simple tab, that the AFCS, the Autopilot tab. The first selection is which, to indicate to the pilot as to which autopilot is in command, either 1 or 2. The pilot can make a selection normally from the cockpit center panel itself. The pilot makes the selection. So this is also another place where we can come to know. Next is the AFCS setting, half bank setting. That is, the bank angles are restricted to half the normal values. So where it is used, it is normally used when the pilot is practicing stall maneuvers during the training flights, because you don't want to experience any violent wing drop, and so you want to make the whole thing smooth. Otherwise, this is normally left unchecked. The last one is the LNAV bank factor, that the range of possibility is between 0 to 15 and default is 7. This basically controls the radius of turn that the autopilot will take to turn on airways. That means if it was 15, it will make a very, very gradual turn. That means it will commence a turn much earlier and then make a gradual turn onto the next designated airway length or airway segment. That's what it means, that 15. If you had put close to 0 or 1, then it will wait till the last minute and do a very tight turn. That means it's a very steep bank angle and a very tight turn. So, but this it's possible that is overshooting. It's not able to meet the demands, and it's possible that it is overshooting the airway. So the system is so designed, irrespective of what the pilot has selected, it will adjust in such a way that the system catered accuracies are not violated. That means en route, if 10 nautical miles are specified, then the system is not going to do it's going to adjust the radius of turn in such a way that it's not going to exceed 10 nautical miles in either way. That's what this means. The next tab is the custom DB tab, where the pilot can manipulate and modify several data which are sometimes may be unwanted. So for that particular flight, so he can delete, as we can see, if there was a previously fed pilot waypoint which you don't need for this particular flight, he can delete that particular pilot waypoint. As you can see, there are several pilot waypoints which are shown on the left window. He can select that particular thing and select that particular waypoint if he doesn't want it. So that confusion is reduced. And there are provisions to delete all pilot waypoints, all flight plans, all NOTAMs, and all databases, unwanted database, custom database. That means which are not fed by the system, or custom database would mean which are fed by the pilot. Okay, now these are all full deletions. Single deletion, deletion of a single flight plan is also possible from the flight management window, and single NOTAM deletion is also possible from the sensors window. That's what here I tried to indicate. And to the right is of course very self-explanatory provision, that is to advise the system as to which FMS should be considered as main. In this case, the FMS 1 has been considered as main, and it tells the system to accept to cross-load the data from FMS 1 to FMS 2 and 3. That's what it means. Now, the last tab, which indicates the system configuration selection, it gives several information, and there are so many pages which are not immediately relevant to the pilot for day-to-day operations or that particular flight. This would be normally be cross-checked or used by the maintenance personnel, and those of you who are interested, then you can derive lots of information by going through these pages. I have not bothered to explain these pages in great detail because I don't think it is important for this particular lesson. Okay, we come to the end of the lesson, and this is a very good beginning to understand the easy cockpit and its provisions. So as we went through these pages, sub pages of avionics, there are several other pages which we are going to learn. This is what the pilot is going to use to start with, to initiate the flight. So I well, it's not complete in many aspects because of paucity of time, and I'm sure in 3-4 flights this the pilot will be able to easily understand as to how easy cockpit configurations and are made. So this will prove to be a very good beginning for a person who is going to undertake type rating, and I'm sure you will find it very useful, and you will find understanding the other systems much easier as you go through. So I thank you all for having gone through the lesson patiently, and as usual, please feel free to advise me of any requirements, and any critical comments is also very welcome. Thank you once again.